Hello.
Hey,
Okay, we're just gonna wait a little bit for some more people to show up.
okay.
Probably start at 7:05. This stream is gonna be about some of the bots functions and what we can do with them. But we're not gonna get into anything too advanced. It's just gonna be more like ideas people could work with for making their own bots. We're gonna be starting in a minute or two. Yeah, it's about Battlecode, of course. Okay, I think we're gonna get started. I'm Aiden, and I'm here with Mark, and we're gonna be teaching you some more stuff you can do with the bots and going over some features with that. So we're gonna be doing a lot of small incremental changes rather than doing any big changes like what we'll get to later with communication and pathfinding. So we're going to start off just where we kind of left off, and then we're going to make some little changes, run the bot against the one, our improved version of the bot against what we had from the end of last lecture, and then make some more little changes and just keep tracking that progress and seeing what happens. Mark, do you have anything you want to say?
Nope, let's get started.
Okay. So first thing, just to remind everyone where we were, is we had we had set up a miner strategy. So in the last lecture, we made it so that the miners will look at squares around them and try to mine, and then made it so that it will also look for squares around it with lead or gold and try to move towards them so that it kind of chases the resources around and then mines them. And this worked pretty well. One interesting change we can do is in the spec, it says that the lead and the gold on the map will, oh, not the gold, just the lead will regrow gradually if it's not fully mined. So what that means is you can mine a lead pile down to 1 lead, and then it will gradually increase. And another interesting thing about it is it's like a constant rate of increase. So it doesn't matter whether you mine it down to 10 lead or 1 lead or 100 lead, like it's going to increase at the same speed. So because of that, it usually makes sense to just bring it down to 1, because that way it will regrow, but you're not missing out on anything that you would get by mining it down to a higher number. So first change is just going to be making the miners leave lead at 1 and not mine the last lead in any lead tile. So this is a pretty quick one. So the first place we got to do it is make it so the miners don't actually mine the tiles with only 1 lead in them. So we still want to treat gold the same because gold doesn't regrow, but then for any tile that has lead, while it can mine it, we were before just mining it, but now we're going to make it so while this robot can mine it, and it's also more than 1. So the sense lead says it returns the lead count at that location. So we want to return the lead count at the same location we are going to be mining, and then just make sure that it's more than 1. And since mining lead only ever removes 1, like each time you call this mine lead function, it'll decrease it by 1. This ensures that it can't mine anything to under 1. And then the one other place we need to make a change is down here in our movement. Right now, it'll mine lead down to 1, and then it'll find a lead that's at 1 and be like, oh, there's still lead there, and keep trying to move towards it. So we also need to, here where we find if there's any resources nearby and look for the closest resource we can move to, we need to ignore lead that has only 1 left. So all we have to do is, instead of doing sense lead is greater than 0, we can change that to sense lead is greater than 1. And now let's take a look to see how this goes. So if we run this, right now we're just running the same bot against itself. Ooh, there seems to be something very strange going on here. I'm going to take a look at that. Sorry. Mark, do you know what's happening? I had the
Not sure.
same. I think it's running like the wrong version of the code because I had the same.
Are you sure you saved it?
I think so. Oh, thanks. Thanks for that catch. Sorry about that. Let me try that again. Right now, it seems like this kill ongoing process button isn't working in the client, so I've been restarting that, but I think a fix is coming for that soon.
Wait. Or Lilypad?
That doesn't seem to have changed anything. Not sure what happened there. Sorry about this. Yeah, so
Are you sure it's saved?
yeah, it is. Saved here. I think it's running the wrong version of something. I'm not sure what. We can try one other thing. Which is another thing the next thing I was going to do, which was making a second version of our example player, so that way we can have our changes in one different from another. And we can play them against each other.
Yeah, let's see.
I think it's
Are you sure you saved it?
so then you can see the second version we made here. I think there's some weird stuff going on with my computer at the moment. It's
Should we
now,
change the package name or?
yeah, I did. It's just the package name is fixed on my end. It's saying that the Gradle Demon isn't running. Really sorry about this. This was all working fine when we were testing it 30 minutes ago. Okay, I'm not sure what changed, but it is now working. And it crashed. But it was working for a second. So for now, I'm going to move on. You could see that the miners were moving around and they were not finishing off the lead tiles. And then that lead regrows at a small rate, which in a longer game, especially on a real map where the lead isn't everywhere, like it was in this case, is very useful. So the next thing I'm going to do is, because we have 2 copies of a code right now, I'm going to actually undo that change I just made from here in the original one, so that a baseline. Oh, my computer just crashed. Can you still see me? I don't think something crashed.
I think VS Code crashed.
Yeah, but is the stream still fine?
Yeah.
Okay, never mind. It could have been worse. Okay, so what I was about to do was remove the changes we had just made from here. So the now example funcs player is what we had before, and we could run it against the other one. But right now it won't make that much of a difference alone. So I'm going to make another improvement to the miners, which is going to be a little more noticeable, but probably not as permanently useful as your strategies would get more advanced. So what we're going to do is make the miners explore a little bit rather than moving randomly when they don't have lead. So how we're going to do this is we're first going to make a direction, explore direction, and set it to null. And so when miner is created, this starts off at null, and then we can use that as an easy way to find the first time run miner is called for this miner. So then if explorer is null, this is if we set explorer here, this is the only time this will happen. So the thing we're going to do is set the explorer to a direction at random. And the directions we have defined in a list here in robot player is directions. So we can do robot player directions, and then we want to get a random number. So same way we did random numbers in here with this random number generator, we got robot player random number generator next int, which will get us a random number up to the max we set. That's not inclusive. And then we're just going to do robot player's directions length. And another thing is that happened here that might happen in some cases is it's importing the wrong copy of robot player there. So I think the fix to that will be just to remove that if it ends up doing anything automatically like that. So now we are setting explore direction to a random direction. And there's like a tricky thing that can happen here that's pretty important to notice, is that this is an instance of this code here is being created for every new miner. And because this random number generator in robot player is being seeded to something, that means the first time you call next int on this is going to be the same value every time. So right now, every single miner will spawn with the same explorer. And we don't want that. So another thing we are going to do here is we're going to change this random number generator. We can do that. We could do it in here if we had an easy way to keep track of the turns, which we could do with turn count. But another easy way to do it is just here. We can set the seed of a random number generator to this robot's ID. And because the robots have independent IDs, this will make it so every new spawned robot has the same, or every new miner at least, because this code's only here for miners, will have a new seed and we'll get a new random direction. And then one last thing, just because it's helpful to see, we're going to set the indicator string for this to explorer string. And that'll be nice because now we can see which way a robot's trying to explore, because especially on the map we are testing it on, it's very hard to see with that because there's so much lead everywhere. They don't actually have to explore much. So now we have to make them actually do the exploring. We have the direction they want to go, but we need to implement that. So they're still going to always prioritize lead. We care more about the lead than about the direction. But if they don't find any target location here, which means that none of the nearby locations had any lead or any gold, then if that target location does not exist, we're going to see if a robot can move in our explorer direction. And if so, we move in the explorer direction. And otherwise, there's two other things that could happen. So down here, we have moving randomly at the bottom of our code. And then we also above that had moving in a direction towards lead. And it might seem weird that we're doing both of these, because if you move towards lead and then randomly move in the other direction, that would mess it up. But the reason this works fine is because each robot only has enough cooldown to move once per turn. So if this one ends up moving here, this can move here is always going to return false. So for that same reason, if it ends up exploring, it'll only do that exploration move. But if for any reason it hasn't moved by the time it gets to the bottom, it'll move randomly, which is fine. And then another thing that's important is because it could explore in a direction right towards a wall, we want to do an else if it's, and then check to make sure that the reason the robot can't move is not because it's at a wall. So if the robot, the position that it's trying to get to, so the location plus the explore direction, if that is on the map, you can't add explore direction. So if this is not on the map, that means a robot's just going to keep pressing up against this wall. And in that case, we just want to change our explore direction. So in this case, I'm going to set the explore direction to the explore direction is opposite. So it'll just go it'll like bounce off the wall almost. And now at this point, I'm going to try to test this and hope it doesn't crash my computer again. Or not my computer, but VS Code. And while this is going, I'm going to try to reset up the share that was allowing Mark to work on this with me. So we want one of them on our new robot, one of them on our other robot, the one that we're building off of. I select the map small here, and we will run that. let's see how this looks. So this is the old robot. You can see they're mining all of their things entirely. This is our new robot. I pause it for a second so we can check out some of this. You can see this robot, or this miner, is trying to go north. This one's trying to go north. This one over here is trying to go east. And if we just continue looking for a bit, we can see that they're making it to the corners. And then, ooh, that's not great. Well, I'm going to keep going. So the next thing that we're going to do is, because it seems like my computer is struggling to stream and also make these changes, is to, and demo it, is just move on to the next small thing we're going to change, which is the archon strategy. So previously, this is very simple. We just randomly try to build a miner or randomly try to build a soldier. So the improved version of this is going to, first, we're going to make it choose a direction that it's going to build in a little more intelligently. And then we're also going to make it make certain types of robots at certain times. So the first step to this is, instead of writing it all in this robot player, we're going to make an archon strategy file. And then we're going to just copy this one archon function out of robot player, drop it into here, and then it gets angry because there's some imports missing. The general import you need is just the Battlecode common with an asterisk, which imports all Battlecode's things. Another thing to do is, now it's saying directions can't find that, and the RNG can't find that. And if we just start all of these with a robot player, we can reference the robot player version of these. And then this is no longer complaining. And then the one last thing we need to do to just get it back to where it was before we made this change is reference the archon strategy here instead of just the one archon we had. And so the first step to our new strategy is going to be making a way to build towards the lowest level. Because if you build your new units on a tile with lots of level, they're just going to instantly be much less able to move and get out of the way for anything else to happen. So with this previous strategy, it's picking the direction completely randomly, and it'll surely be an improvement to build them in tiles with less level. So we're going to make a new function called build towards low level. It's going to take in the robot controller and the robot type that we want to build. And this function is also going to throw game action exceptions. Any function you write is going to have the possibility of throwing these if it uses any of the methods like can build robot. Any of the methods like build robot. And this is interesting because you might be like, oh, we just checked if you could build a robot. So why is it even possible an error could occur here? And the reason this can still happen is because if you run out of byte codes in between these two lines, this second one will get an error. And so the thing we're going to do in this function is we first have to get all of the possible directions we could build something in. So we're going to make an array of directions. And there's a reason we can't just use robot player.directions that I'll explain in a second. So we're going to make a copy of the array. So we take robot player.directions and we copy it. And the second property here is just setting the length to which we copy to. And then you'll see it doesn't like arrays here, but you can just import Java util arrays and fix that. And then the reason we had to create a copy is because we are now going to sort this array. So We don't want to change our robot player directions. So we just want to change this one here. So we're going to sort the array does. And here we're going to use an inline for a lambda function. So how this works is we're creating basically a sorting parameter. So what it's saying is, if you have an A and you have a B, how do you want to sort them? So you put an arrow, and then you put what number you do for the sorting for this. So how that works is, it's basically like this is a inline function here. And if A is going after B in your thing, it should return a number above 1. And if A is going before B, it should return a number less than 1. And then if it does not matter the order they go in, it would return a 0. So what we're going to return is the rubble at A minus the rubble at B. But to make that much easier, we're going to make another quick function called get rubble. And that's going to take in the same robot controller, because we need to pass that to all of our functions to access a lot of easy methods like current robot's location and stuff like that. And then we're also going to take in a direction, because that's what A and B are up here, is they are directions. So as I was saying, we threw a game action exception here. In this case, we're going to use an alternative way of avoiding that problem, which would be a try catch. So we can catch the game action exception right here and print it out, and then return 0 for the rubble, because the only time this will actually happen is if you run out of bytecodes, or if we make some sort of typo in our get rubble function. So it doesn't really matter what it's returning. But all this function is going to do is get the location where your robot is like possibly thinking about, because we take in a direction, not a location. So we get our robot's location and add direction. And then we're just going to return the rubble at that location. So sense rubble location. And now we have this little nice function here, and we can just do get rubble RCA minus get rubble RCB. So now we've got all of our possible directions sorted from lowest rubble to highest rubble. So now we can loop through all of our directions, and just starting from the first one to the last one, we know we're going in the order of best place to build to worst place to build, at least when we're only considering rubble to decide as the deciding factor there. So we're going to then see if we can build a robot in that location of type, which is passed into this function in direction D. And if we can, we're just going to build it. Type in direction, build robot type in direction D. And that's all of this needs to do. So now we need to change our function up here a little bit, because we no longer need a random direction. Right now, we have not replaced this part of the code yet. So we're going to leave that for now. So instead of picking a direction to build in, if you want to build a minor, in this case, we're trying to build a minor, we're just going to call build towards lowest rubble minor, or robot type dot minor. And we also need to pass in our robot controller. And then in our soldier place, we do the same thing, but soldier. And now, at least on the map we're testing on, this isn't going to really change anything, except it is going to make it so it prefers one spot always, because this array is in a certain order. And then when you try to sort it, it's going to make it so a certain position is always first. So we basically removed that randomness, but on a lot of maps, that's more significant. Just the map we were testing on had no rubble. Another interesting thing to think about is you might think, oh, you could cache this sorted array, so you don't have to waste your bytecodes recalculating this, which could be a good strategy. but also because of some of the events that can happen can change the map and change the level on certain tiles, you could also end up with a messed up list of directions there. And then we're gonna make one last change before we pass it off to Mark, and then I'll try testing it again. The reason I've been hesitant to demo this again is because it seems to not be great for my computer. So the last thing we're gonna do is, instead of just spawning stuff randomly, we're gonna spawn with a little bit of thought put into that. So we're gonna make a list of what things we've made and how many of them we've made. So if we have, at the beginning, we have 0 miners, we have 0 soldiers, and we have 0 builders. And then instead of this randomness here, we are going to make a sort of schedule for what we want to create. So the first thing is, at the beginning of the game, your enemy probably hasn't gotten to you yet. So we should start off by making some miners. So if miners is less than 5, we're going to build towards lowest level. We're going to build a miner. And then if we have more than 5 miners, we have to think about like our next priority. So our next priority is, if soldiers is less than 10, we're going to build towards the lowest level soldier. And then our next priority after that is going to be to make a new unit, which we haven't done much with, but Mark will start to implement in a bit. And it's if builders is less than 1. So we have no builders, we're going to make a builder. And then our next priority is going to be to get some more miners. So what we're going to do is, we're going to do if miners is less than soldiers over 2. So if you have more than twice as many soldiers as miners, and then we also don't want to be making miners if we have no need for them at all. So we're going to do, if you have more than twice as many soldiers as miners and your team's lead amount is less than 5,000. Then we make a miner again. And then our next priority is if builders is less than soldiers divided by 10, because we don't need nearly as many builders as soldiers, at least in this strategy, simple strategy we're creating right now. But we still want some. So we'll have 1 builder for every 10 soldiers. And then lastly, our default is just going to be to build a soldier. And one important thing to note here is, without using more advanced strategies, we have no way of knowing how many of these are still alive. All of our miners could have died, and we still only make miners at a rate of half of the soldiers. So that's when we learn about communication, we can improve on that. But right now, we're just going to do it based off how many we've already spawned. So the last step to do that is, we actually need to change these values when we make something. So when we build a robot, we're going to do a switch for the type. So, and then just, you made a miner, increase miners by 1. Great. If you made a soldier, increase soldiers by 1. Great. If you made a builder, same thing. And there are more units than these 3, but besides for 1 unit, which we need gold to make, we can't make those with the archon, we would make them with the builder. And then for that 1 unit we need gold to make, we don't have gold yet, so we're not going to worry about it yet. This default here just handles all of the cases we haven't done. So like, let's say we did call this build towards lowest level on something that isn't one of the 3 things we're keeping track of, it'll just do nothing. And then lastly, we're going to test this, and then I'm going to hand this over to Mark. So here's hoping nothing breaks this time and that we'll get to see our spawning schedule at work. So you can see we're blue because we are not fully destroying any tiles. And you can also see we've started to take up a lot of space around our archon with builders. And also we can no longer see anything. But what was happening there was that the builders have no AI yet. The builders will just sit there. So they are just going to clog up our space. And that's why Mark's now going to implement some of the builder strategy.
Okay. So let's start by moving the builder stuff to its own file. And are you following me, Aidan, or?
Yep, I got it.
Okay, cool. So we'll copy the basic stuff. Okay, so okay. Now let's close the function that we just made. So okay, and first things first, we would want the we would like the builder to move randomly. So we'll use the same thing that we did at the end of the miner. So copying that, and then right here. And so this way, hopefully our builders are not clogging the way. The next thing we would like them to do is we would like them to repair buildings near them, similar to what the miners were doing. So again, we can just try to reuse some of the codes there. So first thing that the miner did was if there's we reuse this loop and okay, so now whenever it's near a building that needs repair, it just repairs it. Okay. The second thing that we want it to do is we want it to head towards buildings that need repair. So we want it to look around and find buildings that need repair and walk to them. So again, we can see how we already did that in miner. Miner was looking for lead. We can similarly try to so let's yeah. So now we find the neighboring robots, and then let's say we head towards any of them that needs repair. So let's say okay, so now we're looping over our neighboring robots. So what do we need to check to know if we want to head towards this robot? We need to check if it's from the same team. So if robot get team equals RC the team, we also want it to need repair. So to check that, we check its health. So okay, and we also need to check that the robot is a building. So do you remember the method for checking if it's a building? See.
I
Oh.
think it should be robot.type.isBuilding.
Oh, I see. Let me try again. Okay, good. So, okay, so now so if the robot is from the same team, it lost some health and it's a building, we need to repair it. So direction would be the direction towards the robot. So see the location. Direction to robot. And let's head towards the closest one, so that we end up breaking symmetry somehow if there are multiple damaged buildings. So let's say okay, and here if okay. So now, once we found a building that needs repair, if we found one, so let's check if we found one, if direction is not null. And RC can can move direction. RC will move action. Okay, so now what we do is we look around for buildings, and if any of them needs repair, we move towards it. And first, if we can repair, we just repair. And now we can. Now we want to start building stuff.
Mark,
So, yeah.
before you do that, I think this line here is a little messed up.
RC will get location, what direction to, oh, yeah, distance to.
Yeah.
Weird, it did not warn me about it.
I think it should be distance squared too.
Oh,
but
okay.
Yeah. And if anyone's wondering why a lot of the distances are in terms of square distance, it's just because if you do all comparisons in square distance, everything works out the same. But it's much less expensive because you never have to do square roots, which you would normally have to do if you calculate the distance between 2 points.
Okay. Yeah, so now when do we want to build stuff? Let's, like a nice strategy would be if you have enough lead, you can just build something, but you don't want to keep building all the time. You want to like spread the watchtowers you're building around. So let's just count the number of turns that have passed since creation, and like build a watchtower every like 100 turns or something. So here's a turn, then and then we would build if so if RC get team RC get team. So if our lead is say greater than 7,000 and turn spin like every 100 turns you can try. And can build robot. Let's build watchtowers for now, because for labs we need to have extra considerations about their location. And let's use the same random direction generated here. See, so and RC build robot. Watchtower direction. Okay, so hopefully now we have a functioning builder. The watchtower is easy to implement, so let's do that quickly and then see how our bot works. So let's add watchtower strategy Java. Oops. Okay. And let's use a boilerplate stuff. So then watchtower. And then it's similar to the solar. We had like a simple implementation of it here. So we can pretty much use the same thing, just removes the moving part. So let's watchtower. And moving. Now let's call this from robot player. Okay. This should be fine. Let's test it.
Yeah, I will try to run it again, but it's possible it crashes.
Yeah.
I will close everything I can before I do that, because I think it's just a little too much open with the streaming and everything. But it'd be nice to get to see one game fully. So let's hope this works. So we're the red team again. You can see we got a builder here. We got another one here. And it looks about right. Like we have about 10 soldiers per builder. So let's keep watching and see if they build any watchtowers. The conditions we made for watchtowers are that you have a lot of lead and it's also only on round multiples of 100. So
okay, sounds like we got a
hopefully
watchtower.
there's some watchtowers.
Has it been repaired from prototype to building?
Yeah,
So
you can see they are smaller and have the red background when they haven't been repaired, and then the builders go repair them. And you can see because of our strategy for making units, we're basically only making soldiers and builders at this point. We have like no more miners, which might be a problem with our plan, but it also seems like we have plenty of lead
Yeah,
because we have filled half the screen. And at this point, I think we can watch it out, but I think because neither side really knows how to go find the other side, it's not much is going to happen besides some conflicts near the middle.
Yeah.
However, it definitely looks like we're winning. That's one thing. We have a lot more units.
yeah. It sounds like keeping a little bit of lead really helped in this map because
Yeah,
Too
because
much
we've
lead.
grown to full lead in this whole area.
yeah,
Also, we caught up to well,
well, we saw the interesting part.
we saw the interesting part. Yeah, the rest of it would have just been more of that. Maybe eventually our side would have found the other side's archon. But that's it for the features we are going to show off. Sorry about the technical difficulties at the beginning. And if anyone has any questions, we'll be around in Discord for office hours. And besides that, thanks for coming.
Thank you.
Bye.